what we're suggesting then is that perhaps 5 million people a year are getting blood with the assumption that it's helping them, and in some, if not many cases, it may even be hurting them. The answer really lies in a new understanding that it is not how much oxygen is carried by a red blood cell or by the blood, but rather by how well that blood can open up a blood vessel and get the blood or get the oxygen to the tissue. If blood can open up blood vessels, the oxygen will get to tissues. Hearts will be supplied with adequate oxygen, the brain will get adequate oxygen, patients will do well. If red blood cells cannot open up blood vessels, the oxygen will not get to the tissues in need of oxygen, regardless of how much oxygen they carry. So now the question arises as to why bank blood is different from the blood in our bodies. And one answer appears to be that our blood loses a critical gas called nitric oxide, whose responsibility is to keep those blood vessels open. So in effect, stored blood does not have the ability to open blood vessels. Unlike our blood, which is opening blood vessels, dilating blood vessels, making sure that blood flow is improved to organs in need, such as the heart and brain, blood in blood banks is not able to do this. And consequently, we give blood, but we do not improve blood flow. What happens then is that those red blood cells effectively plug up blood vessels that they would normally be dilating. So instead of helping, they end up hurting. They end up sticking to the blood vessels and blocking blood flow. The solution, we think, to the problem is to put back the nitric oxide that is deficient in our bank blood. And we've worked out now a way to do this. And we have put back the nitric oxide that is quickly lost, and we have infused that blood back into animals, and sure enough, it then opens blood vessels and it improves flow to tissues that are in need of the oxygen, in need of the blood, so to speak.